Good morning, everybody. Today we are looking at chapter 3.4, where we are going to discuss this idea called slope. Slope, right? Slope is a very big idea, right? It's a huge idea in mathematics. In fact, I will tell you right now that slope is the foundation for calculus, right? It's a huge part of calculus. It's a huge part of what I do in AP statistics. This idea of slope goes into many different facets of mathematics, and it's extremely important idea. So we're going to do the very beginning today, and we're going to use the slope formula to calculate the slope. But when we're done, after this today, we're going to have a couple of days where we look at slope in context and look at some big ideas and what slope really means. Okay. So that's what's coming up. Today we're just going to learn the very basics of what slope is, and then we're going to continue and try to learn that in context, get an idea of what it is. So the slope, here's some vocabulary to add to your algebra sheets. The slope is the ratio of a non-vertical line, right? Remember, vertical means like this. Okay, that's vertical. So we're not talking about vertical lines. Comparing the vertical change, also called the rise, to the horizontal change, also called the run. So to give you an idea of what we mean by that, let's just make a quick graph down here. Pictures help a lot when we're talking about slope. The slope is a very visual idea. Let's take this point right here at 3, 0, and we'll take this point right here at 0, 2. And we have here an increase. So notice, if we were to draw a line between these 2 points, we would get something like this. Okay? Another way that we might describe slope is kind of like the steepness, not teepness. That's not a word at all. Is the steepness of the line. It is just how steep it is. It is a number that represents how steep something is. So the way that we kind of want to think about that is how far is it traveling horizontally? So this is its distance traveling horizontally. And how far is it traveling vertically? That is the distance vertically. And the thing that's important to note here is that distance exists for the entire line. No matter where we are in that line, we're having a horizontal distance that is about 3 and a vertical distance that is about 2. If we were to add a couple more points on here, vertical distance of about 3, horizontal distance of about 3, vertical distance of about 2. So what the slope is it's a number that represents that. So in this case, it's the vertical change or the rise. So it's vertical change over the horizontal change, which we might also call the rise over the run. So in this case, the rise is 2, and the run, the horizontal change, is 3. So that's what my slope would be. My slope would be 2/3. Slope is a measure of steepness, okay? And again, we use this kind of thing everywhere, in everything from building a house, because when you build a house, you have your roof. And the way that builders build a roof is that there are certain codes that they have to match. If you're in town, you can have a house that looks like this. But if you are in the mountains, your house would have to look more like this. Because when the snow falls, it has a steep roof so that the snow falls off your roof. Whereas if you were to build a house like this and snow started falling in the mountains, that snow is going to build up and eventually it's going to crash through the house, right? There's going to be so much weight. So in the mountains, they have to build things with steep roofs. So there's a certain slope that needs to be present. And builders have to take that into account when they're builders, architects, anybody who's working on a house has to take that into account when building it. Because if you built something with a flat roof on the mountains, when it snows 20 feet, that's 20 feet of snow on top of the house that's going to weigh it down and crash it. Okay, so slope from building that we need that. Everything from like economics to psychology to, I mean, there's a lot of things use slope. Let's use the formula here. So we have a formula to help us calculate the slope. So in the formula goes like this: m equals y2 minus y1 over x2 minus x1. Here the m is the slope. Okay, and then the y2, y1 are y coordinates, and the x2, x1 are x coordinates. So let's do an example. We want to find the slope between the points, and what are my 2 points that I'm going to use here first? Negative 4, 2, and 2, 6. So we're going to find the slope between those two things, between those 2 points. So let's look at those 2 points first here. And something that we want to recognize here is that this point right there, we'll call that x coordinate, x1. The other x coordinate is this one, so we're going to call it x2. And then the y coordinates here are that 2, so that we're going to call that one y1. And that one's y1 because this one is x1. They should share the 1, right? So this is xy point. This one over here is going to be y2. Let's I'm gonna fix that because that one doesn't look like a 1. Let's make it look like a 1. Yeah, okay. And so with that information, we can actually just plug this directly into our formula to figure it out here. So if we have m equals, and then let's do my y's first. That's y2, so we're going to do 6 minus 2, right? That's where those numbers are coming from. Follow the colors, and then that's going to be divided by my x's. So there's x2 minus x1, 2 minus negative 4. Notice that that negative 4, there's a negative in the number, there's a negative in the sign, or excuse me, a formula, so you make sure that that's minus a negative. And then we end up with, then we just do the math here, right? 6 minus 2 is 4 over 2 minus negative 4, which is positive 6. And then we can reduce that because they're both divisible by 2, so that's 2/3. And so that's my slope, 2/3, right? What that means is that I'm going wherever I'm at on my points here. Let's just draw these 2 points. Negative 4, 2, which is there, and 2, 4, 5, 6, 6, which is right there. If I were to take a rise like that, and the run like that, I would have the ratio 2 to 3. We would actually have this happening twice. Like, what would actually be happening is that run would be coming up twice, because that's going to come up there, and then this is going to come across there. So that's 3, 2, 3, 2. But the full ratio, 2/3. So finding the slope between 2 points, we can use our formula. 2/3 means that we're going to the right 3 and up 2, right 3 up 2, right 3 up 2. So another example. Keep my slope formula up there. y2 minus y1 over x2 minus x1. And let's do another point. This point is going to be 3, 5, 3, 5, and 6, 1. 6, negative 1. So again, color coded, there's my x's. There's my y's. This is y2. This is y1. This is x2. This is x1. So this is going to be m equals 6 minus 3. There's the 6 minus 3. And negative 1 minus 5. Which ends up being negative 6 over 3, which reduces down to negative 2. So that's my slope. And again, let's draw a quick picture of it. 3, 5, 1, 2, 3, 1, 2, 3, 4, 5 is right here. And then 1, 2, 3, 4, 5, 6, negative 1, that's this point right here. And so what that tells me is that if I were to connect a line between those two things, that if I were to go down to right 1, down to right 1, down to right 1, down, wait, I messed something up. Yep, ignore that last line. Ah! Okay, you get the idea. I don't want to draw the whole thing out again. I'm going to go down to right 1. Down to right 1, down to right 1, down to right 1. It all gets me in the same spot. Of course, I deleted it and messed it up. But, so that's my slope, right? This is negative 2 over 1. Down to right 1. Let's do another example. Come on now. You want to do that. Uh-oh. Uh-oh. I locked up. Alright, we're back. Sorry about that. My thing locked up. I don't know what that means. So we're gonna try this again. We're gonna do 2 more quick examples of other things that might happen. So let's take a couple more points. Negative 2. What just happened? Stop it. Bad thing. Negative 2, 4. Okay, yeah. And the point 4, 4. And let's find the slope y2 minus y1 over x2 minus x1. Ugh, this just looks terrible. Everything's falling apart, people. Okay, there we go. So, let's do it again. y2, y1, 4 minus 4 over x2, x1, 4 minus negative 2. 4 minus 4, that's 0. That's weird. And then 0 over 6. So, let's analyze what this is saying a little bit here. That this is the rise over the run, right? So this is saying that if I were to start at a point, let's go to negative 2, 4, that one right there, that the slope here means rise of 0, so I'm not going up or down at all. I'm just going to go to the right 6. Boop. There it is. And then right, up, down 0, right 6. I'm getting another point over here. What kind of line does that make? Horizontal. So when this happens, the 0 over 6, we call that 0, right? 0 over 6 is 0. So it has a slope of 0, which means that it is a horizontal line. And if you may recall, horizontal lines mean that it's a y equals 4. Because remember, the y's here are both 4. So y equals 4. Slope of 0. Let's look at one more special case. and then we'll kind of be done here. The last 2 points, 3, 5, and 3, negative 1. Again, my y2 minus y1 over x2 minus x1. So, y2, y1, negative 1 minus 5, over x2, x1, 3 minus 3. So my slope is that. Negative 1 minus 5, that is negative 6, and 3 minus 3 is 0. Now that's a problem, because you might remember that you cannot divide by 0. That is not 0. When you're dividing by 0, you can't do that. If this is the result we have, this is actually undefined, right? Undefined is what we call that. But what does it mean in the terms of the picture? What does an undefined slope mean? Because this is still rise over run. So what does that mean? Well, let's go to one of our points. 1, 2, 3, 1, 2, 3, 4, 5. That's this point right there. And what this tells me is to go down 6 and left, right, 0. So there's my other point. Down 6, left, right, 0. So there's my line. Straight up and down. Remember, we call this a vertical line. And the equation for it was x equals 3. Because remember, x is 3, x is 3. This line, x will always be 3, so it's x equals 3. Alright, I've got an assignment for you where you're going to practice just using the formula to find slope. Like I said, the next couple of days we're going to practice just getting a feel for what slope means in a variety of different contexts. Because we can use it, like I said, in the roof example, but we can also use it to depict speed, and we can use it to depict just how fast something is growing. So there's a bunch of different contexts in which we can use it. So that's what I've got for you here today. Go ahead and grab your assignment. Thanks.